Excuse me. Okay, guys, we are on a journey. I will just finish with the classes. Then if you follow, let me know. If you don't, for yes, people always say my questions are tricky. Please, so don't. If you feel I don't quite get it, let me know before you give me the wrong answer. Are you okay? So please follow it very well. It's okay. Yeah, people have told me, and
Yeah, that one there is true.
You realize that who is this? Who's speaking?
Henry, say all of us have realized.
We have to be very frank with ourselves, and so I'm being frank with you. I've heard it over time. It's like maybe it's a talent. So I'll let you ask questions in a few minutes so that I know you get it. I don't want to even make guesses. So like I was saying, here is the so-called cylindrical. Oh yeah, of course. Sorry, I thought I did. Share my screen. Okay, I go. Hey, okay, I can actually do a whiteboard and all that. I think I haven't explored that yet. Excuse me. Okay, so you can see that, yeah, here we go. The so-called cylindrical projection. Are you okay? So he's using a cylinder, and then the equator is here. All right. So this is the equator. The equator is actually 0. Are you okay? In other words, it's a reference line. Okay. So that all the latitudes going up are reference to it, of course. Then there's a Greenwich meridian, which is also going that way. It's also 0, and then all the other longitudes reference to it. Are you okay? Then we have the North Pole up here. Okay. So someone said use a cylinder, wrap it around the Earth so that it touches the Earth. Are you okay? And in fact, there are variants of it. Someone said let it cut through the Earth, and then again project everything on the Earth onto it. In other words, project everything on your project area onto that. Then there's a transformation, and it's mathematical. Then when you finished, open it up. So this is the developed cylinder. So the transformation from here to here is really a transformation from longitude and latitude. Okay, lambda and phi to x and y. Okay, so like I said, this is being done by software. You press a button, you tell it, I want to move to this one, and then it does it and uses the formula that I showed you. And then now you have your data on, a flat surface, not on curved lines, because the longitude and latitude, they are kept. As they go to the top, two lines that are parallel shouldn't meet, but you see that they are meeting up here. And that's where the challenge is. Are you okay? All right. So this is the so-called cylindrical projection, or the class, another class of projection. So the first class is called the planar or geographic or the azimuthal projection. Now the second class is the cylindrical, simple. Are you okay? Now something very interesting about the cylindrical projection is also later going to be used to create one of the most popular map projections, which I'll touch on maybe briefly, then we can go. All right, so this wasn't the end. Someone said, no, you're not done yet. You're doing this for Africa. Are you okay? You're doing this for Brazil and Southern America and stuff like that. Okay, those around the tropical regions. You're using the cylinder for them. What about those in the temperate region? UK, Japan, Asia, China, where the coronavirus is coming from. Why do you call up those places temperate? Because, let me just say that the weather can just change, in a short while. There's a lot of variety. Are you okay? In terms of weather, the wind speeds can quickly change. The snow falling, it's raining, and you're having a whole lot happening in terms of the weather. But then he said, okay, then let's do something for them. All right. So you have the round Earth, and he said, do something like for the Christmas hat for it. Use a cone, go over it like that, and then when you're done, open it up, cut it, project the longitude and latitude on it, and then open it up like some farm milk. Okay. Symbol, do you know farm milk? Those in Ghana, we are used to what we call farm milk, so ice cream. Are you okay? So the longitudes now become these straight lines. Latitudes also come through like that. Meanwhile, up here, we still have our latitude going through like that. Are you okay? And then, of course, North Pole is up here. South Pole, South Africans are down here. But the area where the error is minimized is always going to be around where it's touching. Are you okay? So we go back up, wherever this developable surface, which is cone, plane, or cylinder, wherever it touches, we have the error being minimized. Obviously, you know that's where Ghana is. So we are around the equatorial region. So that is why such a projection will work for us. Are you okay? So you can definitely see that what I'm saying is true. And I'm not lying to you, because just where it touches it, that is where I've just described. You can see that here, the North Pole. So for the polar regions, you want to use the planar projection for it. And then for the equatorial region, if you say the tropical regions, then we're going to have the cylindrical projection. And then for the temperate regions, Japan and Asia, China, they are all around these places. Are you okay? All right. So we can now, as you can see, that is the belt up here. All right. We can now have, we've covered every part of the round Earth. Are you okay? Because of course the Earth kind of bulges around the equator and then it kind of flattens at the top of the polar regions. Are you okay? So now this is the concept of the classes of projection. Are you okay? And you need to appreciate the data that you are having has gone through a certain projection, which is probably stated in your metadata, but you should understand, okay, all right, I'm getting data from the poles. I'm working as an engineer, okay, at Iceland. Yeah, most of you, we study in Africa, we study in Ghana, we study in Nigeria, but when you travel to the UK, you realize that now things have changed. You need to appreciate some of the concepts that you are being taught. You never know where you'll be as an engineer. And you'll be thinking, what is that? Are you okay? But yes, depending on where you are, there's a particular map projection class that will work for you. Are you okay? So that your data can be transformed. Okay, and it's the transformed version of your data, are you okay, that you want to actually use as an engineer or whatever the solution provider. Okay, so let me quickly say this one. Then if you have a question, you can ask. If you have the round F like that, one of the things that you can do is that instead of you to put the cylinder here, okay, you can decide to rotate the cylinder. Are you okay? So you actually put it this way. So that option is there. Okay, so bottom and top of the cylinder. Okay, and then you can have the round earth. And then instead of you putting it in such a way that it is normal, the first one I showed you, or making it this way, which is transversal, you can also make it this way, oblique. Okay. So that it's neither here nor there. It's not normal, it's not transversal, but it's in between the two in terms of orientation. Okay, when you do that, this is called the aspect of the projection. Excuse me. So we have the normal aspect, have the normal aspect, ASPECT. You can have the transverse aspect, transverse. Then you can have the oblique. Okay, so the oblique is the one I just showed up here. Okay, so that's oblique. All right, So now we have classes and aspects of projection. Is that okay? We have different classes. You have 3 different classes, and we have 3 different aspects of projection. So you can have, let me give you a typical map projection. When you see it, sometimes you are being taught not because we want you to go and do something about it. We want you to, when you see it, you don't get scared. Are you okay? You have Albert's equivalent, conical, are you okay? Projection. Okay. At least you appreciate one thing, that you are seeing conical. Are you okay? All right. Anyway, plenty talking. I would like to hear maybe a few questions, but because if you get it brilliant, I'll be so excited. My job is done. And then I will talk about the last topic, then we go. So, do we follow the concept of map projection? Or maybe a question. Sometimes, me when I was not when I was, but when I'm a student, I like to ask a lot of questions. You know, life trick.
Okay.
Funny question. No wonder I'm asking very difficult question. Yes.
I was wondering, especially the cone projection.
Okay, the conical.
The conical and the cylinder.
Mm-hmm. The cylinder. Okay.
Yeah.
Cylindrical,
yeah,
and conical. Mm-hmm.
yeah. I was confused if your position will affect your result, your end result, as in X and Y
and Y.
section. Yes.
Mm-hmm.
So I was wondering. So when you brought the concept, like the aspect.
The aspects, yes.
Yes, I was a bit clear, but then my major question is outside this, but then it relates to this. What will you? How is there any way without using any device? Is there any calculation that will tell you anywhere you found yourself, determine whether you are in the north or in the south or east part of the globe?
Okay, if your problem is to find out whether I'm the northern hemisphere or the southern hemisphere.
Yes.
Is that a question, right?
Yes, please.
Okay, that's good. So let me just draw it here for us. And you can see that it's the equator that makes the difference. So the equator goes round, turns and goes back and comes back to where it started from. Okay, so now the top of it is the northern hem. This is the southern hem. Are you okay? Now the equator is the line of 0 latitude. Are you okay? All right. How do I know if I'm top of it or south of it? It's very simple. We just append north to it or south to the value. So if I am 50 degrees on top of this equator, then 50 degrees north is the indication. And then if I'm actually down south and I'm 60 degrees south of the equator, so these are the values. Now, instead of you saying 50 degrees, you can also say minus 50 degrees. And, or, oh, sorry, 50 degrees in this case is positive, and then negative 60 degrees will tell you that you are south. And so the coordinates are normally given in pairs. So we talk about coordinate pairs. Remember, I was trying to touch on coordinate pairs. You have 2D, 3D coordinates, 4D if you like. So longitude and latitude, normally you want to arrange it this way. And then if the point of interest is actually down here, let's say this is the greenish meridian, which is the line of 0 longitude. Then in that case, the intersection of that with the 60 degree defines a point, and that point is actually the intersection of that. So I'm just going to go down and I'm going to write those sets of, that point is going to be defined as, my longitude is what? 0, isn't it? So 0, comma, and then my latitude is actually 60, minus 60. Now, anybody who sees this knows where you are. And so it's enough to get you killed. Are you okay? Okay, yeah. So it's actually the normal coordinate system that we used to, except that there's a plus and minus, which is we need to take note of, that longitude and latitudes are more or less like something like that, where this is the equator and that is the Greenwich meridian. Okay, so if you are here, then you know you are negative, negative. You are here, you are negative, positive. You are here, positive, positive. If you are here, you are actually so negative, 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 positive, positive, negative. Are you okay? So it defines the coordinates themselves will define where you are. Are you okay?
Yeah.
All right. Yes. So I don't know if I've made an attempt to answer you.
Yeah, you're good, sir.
Okay.
Yeah.
So it's as simple as that. When you take the device, without a device or without it, the coordinates tell you a lot. So sometimes when someone fakes to be an engineer, for example, one of the ways to get to know is just ask them what kind of value you're holding, and they already know. Very simple. Are you okay?
Yeah.
So the values tell a story. There's a lot that the value is actually telling you than you can even think in terms of, are you okay? For example, if I'm giving you values that are very small, if I say I have a set of coordinates and I say, give me the coordinates, you start saying 5.4. Straight away, I know the kind of coordinates you are dealing with. And can anybody in the class tell me why I know the kind of coordinates you are dealing with? Because these coordinates are not real. When you go to any spatial data, you know, people who are supposed to keep it, like Lands Commission, surveyors,
Yeah.
they will see this to be a joke. What are you talking about? Are you saying this is a coordinate? But what is this is actually telling you that this is not projected. It's when it gets projected, then you have the huge numbers that most surveyors will transfer to a project site for the whole project to start. Are you okay? Uh-huh. But obviously, we are talking about different coordinate systems and how we can do overlays. When we talk about GIS, we almost move out a little bit into surveying. We come back out of it, and then we are into GIS. We use it for what we need it for, and we continue the way we want. So your question is very, very good. It's actually, helps us to bring out the meaning of the values. Are you okay? It's very important to appreciate the values. Are you okay? Even though we are looking at concepts here, let me just say that what we are talking about is just introducing map projection to you, because the map projection itself, you need to look at the flattening of the earth, and factor all that into. And even if you know how this formula works, when in actual fact you won't be going to, surveys and mapping division and see them calculate with a formula. They will be using a software, and they themselves haven't even. If you give them a question, so they may not be able to solve it. So it's always integrated into a software. AutoCAD takes the coordinates as they are. I like AutoCAD. I like computer aided design. Whatever coordinate you give it, it takes it to be projected, and then he gives you his coordinate system in the form of grids. Are you okay? Regular, equally spaced grids. That's how AutoCAD works. There's no projection going on there. So we need to appreciate that. Even though they are trying to integrate AutoCAD, building information models with geographic information systems, we need to appreciate that they're not there yet. Are you okay? They're not there yet. Because the idea is to borrow some of the functional things that are done in GIS and then bring them into CAD, which will now make the engineer totally in control. He can just be there and be doing things that previously couldn't be done. Okay, so if there are no further questions, then I can actually talk about, let me just say, the implementation of map projection or in a popular map projection system called the UTM. Are you okay? So one of the popular geographical coordinate systems that you meet will be the WGS 84. Okay, these are names. Remember, it's good to give a name to something. Are you okay? So that you know which particular one you're dealing with, whether it's the bad one or the good one. Are you okay? So the UTM actually is a popular projected coordinate system. So in GIS, you'll be seeing projected coordinate system and then the geographical coordinate system. In it, whichever way it's said, if you understand it, if they are using another term, you still know they are trying to talk about projected and then spherical coordinate system, geographical coordinate system. Now you're like spherical, geographical, longitudes and latitudes. Okay, that's WGS 84. And then the UTM is the projected one. It stands for Universal. Writing on this is interesting. Transverse Mercator. Okay, so these are names. Obviously, you can relate to the transverse. Everybody in this class can relate to the transverse. It tells you the orientation of the cylinder. Okay. So the UTM is actually a cylindrical projection, and universal is saying that anybody who says something is universal, he's saying you can use it anywhere. In fact, there's this charger, they call it the universal charger. Yeah. Anything you want to charge, it will work for you. Even though the ones I've bought, they are all fake. I don't know. Maybe China grade 4. I don't know. So universal means that anywhere you are on the globe, you can use the UTM projection. So that because what happened was this: someone would do something in Russia, the data is in some kind of panic coordinate system. Then someone would do something in Ghana, they use some kind of war office, something, depending on some war that was happening at the time. So we needed some kind of way to standardize. Okay, so UTM comes to be a system that has been accepted by many. Okay, so it's universal because any part of the earth you are, it can be applied. It's transverse because of the orientation of the cylinder that is being used, the concept. The Mercator is a human being. You see, it's like his name has been named after it. So you can just say that universal transverse, then we pick a name, maybe Austin. Universal transverse Austin. Think about it. Okay, but because our grandfathers have not, is everybody in this class actually an African? Okay, I'll just say that we don't have our names appearing in most of the literature. Okay, so we have to, some things scare us for nothing. This could have been universal transverse, you put your name there. Are you okay? So Mercator, he was trying to find out the shape of the earth, understand how the world works. He was seeking God. Let me put it that way. I'm coming from church, so you can see them in the spirit. All right. So universal transverse Mercator. So it's actually a cylindrical projection. Is that okay? It divides the earth into 60 zones. So there's a zone system. So can you imagine zoning the earth, going all the way, 60 of them going around? Are you okay? And then you get strips. In other words, Ghana is actually in the 31st, 30th, and the 31st zone. So we are in the zone 30 north, 31 north. So Ghana sits on between two zones of the UTM. So it divides the earth into 60 zones. What that means is that every zone has the width of, can somebody tell me? I always ask the class that I'm teaching, if I divide the earth into 60 zones from north to south, what will be the width of every zone? I'm waiting for the answer from the class. Okay, nobody's minding me.
You say
if I divide, okay, so it means you are not paying attention. No, okay, class rep.
Yes, sir.
Are you there?
Yes, please.
Are you paying attention?
I went out to ease myself. I just came back.
Hello? Hey.
Yeah.
Serious. Okay, yes. Someone is giving the answer, please. What's the answer?
6.
Oh, no, you didn't hear me. The question is, you have the earth, you are dividing it into 60 zones, and you are getting an answer of 60 zones. So it doesn't make sense. You are getting an answer of 6 zones. So you have the Earth, the round Earth. You are dividing it from in a north-south fashion, and you are dividing into 60 zones. What will be the width?
Hey, so you say
What will be the width of every zone? Are you here?
okay.
What will be the width of every zone? Okay. Class rep, let me take attendance quickly. I just want to check something. Okay, so everyone online, kindly let me just class rep is already here. So I'll just see. Yes, Austin is here. Henry is here. Okay, so let me hear your voice. Apart from Austin, Abeliga, and Austin and Henry, please let me hear your voice. Let me hear you. I just want to write down your name.
This is Ben.
Please, I'm taking a class attendance. Let's pause. I'll come back to the zones.
Ben.
I felt Ben. Okay, Ben. Okay, so I hope you're the only Ben in the class. Next,
Eric Lampe.
Lamptey.
Eric Lampe.
Eric. Okay, Eric.
Yes.
Okay, next.
Christopher.
Christopher. Okay. Is that all? Let's go back to the zones. So these are a number of people who have been showing up actually. 1, 2, 3, 4. Okay.
Ingoma, sir.
Ingoma. Okay.
Yeah.
Okay, great.
No. ENG, sir.
EN. Is that fine?
That's fine.
Okay, great. All right. So let's go back to the zones. Someone give me the answer, please.
So you say you say if you divide the weight of each zone.
What the width? Let me write it down. I need the width. Width of each zone. No, what is this thing that is bothering me? UTM zone.
Okay, a minute.
What is the answer?
5 minutes.
Say again.
A minute.
Okay, that's fine. I'm waiting for the answer.
So it will be 212.36.
Yeah. Okay, easy. Well, I really said 200. I didn't want you to say end. Are you okay?
Okay.
All right. But you tried, but what's the justification for the answer anyway?
212 kilometer. So,
hey, Preku, how do you come by that? Tell me.
So you take the width, the complete width of the Earth, which is 12.70.
So you are using the actual
width of the Earth.
The circumference of the Earth.
Yes.
You didn't use the circumference.
Yes, I was using that.
Okay.
So
it's not a bad. It's not. In fact, it's not a bad idea at all. You can do something like 2 pi r. And
okay,
then
2 pi r.
The radius of the Earth, and then you can do that. But in fact, this is the first time I'm getting such an intelligent answer, and so well done. I've never had anybody try this kind of thing. But anyway, I was expecting it in degrees. Are you okay?
Okay.
So the person who actually said the answer is 6 zones, he wanted to, all he needed to do was to say 6 degrees, and that would have been the best answer for this one. Because it's like 360 divided by 60. Are you getting it?
6.
Yes. Okay. So yeah, well done. Okay, so the UTM employed this zone system where the whole Earth is divided into 60 zones. Are you okay?
Yeah.
The UTM makes use of what we call the false northern and the false eastern. What is this thing that keeps showing up? Northern. So northern is spelled northern, not northern region. Is that okay? Then we have a false eastern.
So I have less than 10 minutes.
Okay, we have less than 10 minutes. Yeah. So I'm done. So we are ending the class. It has a false northern, false eastern. The false northern is actually 0 for the northern hemisphere. And then it's actually 10 million for the southern hemisphere?
Yeah.
Meters. Are you okay?
Yeah.
All right. So this is 0 meters, and this is 10 million meters. Let me tell you why the southern hemisphere is 10 million, because this actually the false northern, it makes use of the equator as a reference. So it's like you are doing a coordinate system in which the equator defines the x. Are you okay? So that x, if I'm in South Africa, I'll be getting a negative value. Because of that, I will now assume that that x has a value of 10 million, so that all the values in South Africa will be positive. You get what I'm saying?
Please come on, come on, yeah.
This is it. I'm just saying that for the false northern, it is 0 for the northern hemisphere, because if as I go up in a graph, I get positive values. As
Yes.
I go down, I get negative values. So if my equator is my origin, then it means if I'm in somewhere South Africa or Southern Africa, southern part of Africa, I'll be getting negative values if I keep using the zero,
0 meter.
what do you call it, meters.
Okay.
But you see, we avoid negative values in surveying and survey engineering, not civil engineering, survey engineering. So, and of course, survey engineering is civil engineering. So we try to keep the northern, yeah, try to keep it what very high value, so that we get like positive values down south. Are we good?
Oh yes, sir.
Okay, and then I'll draw something for you. Then the first eastern is 500,000 meters, which is actually the line that defines that is called the central meridian. So you know what the meridian is? The meridian name for the longitude is the meridian. Are you okay?
Yeah, yeah.
Okay, so now you'll be seeing all these things in your GIS software. That is why I'm teaching you. You don't even need it to scare any little kid. Are you okay? You just need it for your own, feeling okay and being at peace. So now,
Okay.
that is it over there. 510 million and then 0 meters. Okay, so if I'm to draw, then it will look more like the round earth then again. Okay, so 0. Are you okay? So those down here, you're going to get negative values. Here, they are getting positive values. So at a point, use 10 million. And at a point, use 0. Okay. So these are the characteristics of the UTM as a projected coordinate system. Are you okay? And it's making use of the formula that we saw. Remember that lambda equal to x and then phi equal to, are you okay? Those length tan phi plus pi over 2. Are you okay? And then for every zone, there's a CM. So this is the zone. So 6 degrees. And then there's a central meridian that goes in the middle of it. So the central meridian will go something like this. So that becomes the origin. The origin is now defined by the CM and then the 0 latitude, the equator. Are you okay? Or, so depending on where I am, 0 or 10 million becomes my origin. The origin doesn't mean that's where I am, but I'm using it as a reference for my coordinate system. Okay. So here we are with the UTM. Is there anything else? I think we need to also know that there's distortion, and the distortion is very good. There's a scale factor of 1.2 scale factor. Now, if you don't know what scale factor is, then you need to go and review your math book from class 5. Okay, it's in there. It actually indicates if a scale factor of 1, it means there's no transformation, there's no change, and I prefer that. Okay, so after the one earth has been projected, if a scale factor of 1 is observed, it means that I didn't change, the object didn't change. The road width, let me just see, if it's a long road running from maybe an airport runway or something, very long one, it didn't change. So that's what I want. But UTM makes sure that the central meridian it's actually having 0.996, okay, 9996 or so. And then the edges, at the edges of the zone, we have 1.0003 or so. But you can see there's something interesting about the two values. What's that? Class rep, this question goes to you. What's interesting about the two values?
Oh, it's just the inverse of let's say you take one.
No, take your time and look at it well. There is something about them, the two values. Look at it. Just look at it carefully.
We have 1.000, and then we have 0.
How related are they? How related are they? Have you seen two people who are short? What do they have in common? Two people who are short.
Oh,
they are height in terms of height, isn't it?
Yes.
So they always see each other and they just say, "Hey, what's up?" Right?
Yeah.
So these two values, you can see that they are almost the same, isn't it?
Yeah.
They are approximately what value? Look at it well. The two values are approximately
the same.
One.
Yeah, the same.
And remember, they are approximately 1. And what did I say about 1 in terms of scale factor? 1 is what you want in terms of scale factor if you are doing any transformation. So the projection, UTM projection, does have these interesting characteristics that I want you to know. Are you okay? Now, everything that I've said is actually, let me just say, 2D. Are you okay? We need to also recognize that there's what we call the datum, which every engineer needs to know, but I don't want to go into that. I think it's just too much, but you need to understand that the heights are also important. Are you okay? Understand that. You are transforming the earth and all that. What about the heights? Yeah, what about the heights? Are you going to leave that? Consider that also. And so that those things are called a datum. For every project you are doing, you need to know there's a baseline of a sort. Are you okay? So all that needs to be considered. Okay, guys, so this is it. The end of it. Silly question. I think the time is almost up with the Zoom thingy. Any questions? Any questions? I think I'm yet to actually look at your midsummer, but I looked at one. It wasn't that bad. Anyway. If no questions, I think we've come to the end of this. Next week we'll continue. Yes.
The software asks how to download.
Yes.
I think I've downloaded the software, but it looks like
Yeah.
I don't know.
It looks like what?
Like a command. If you open it, you ask you to put a command to continue all of that.
Command, it's not a command. It's not a command line.
Yeah, it looks like something like that. Or did I go to
Then
wrong?
you got the wrong one. Maybe you're opening a different. What you need is
desktop.
Every software. Let me tell you something. Every software, and there's a way to interact. You can interact through the graphical user interface or through command line. That's one. Every software can come in a mobile. So what place your so that I can understand what you're saying. Where's the issue?
Can I share my screen and show you how it looks like?
You can share your screen. Yeah, please share your screen. Yeah.
Time. Allow me time.
Yeah, we have time. We have about how many minutes do you have?
Oh, we don't have much. I think 1 minute or